So let's take a look at our radicals. So the first thing we need to look at is what a square root is. So we kind of remember square root of 16 is 4, but we got to know why the square root of 16 is 4. What's going on the square root is there's an invisible 2 that's sitting right here. That 2 right there, that's my index. It tells me how many of something that I need on the inside to be able to take one out on the outside. And the square root of 16, that 16 we can rewrite as 4 times 4. The stuff that's inside, this is the stuff that's the radicand. And that 16, like I said, I can rewrite as 4 times 4. The fact that I can rewrite it as 4 times 4, that means I have a set of 2 4s. My index tells me how many I need in my set. Here I have a set of 2 4s. Once I know I have a set of 2 4s, then I'm able to write the 1 4 out as my answer. And so that's where the square root works. You need to know what can you multiply times itself 2 times to get that 16. And the answer is 4. 4 is the number that you can multiply times itself 2 times to get the answer of 16. So again, for the notations, the square root is that symbol. We have the index. I call that the number on top of the house. And the stuff inside the house is called the radicand. And so we can have a square root. We can have a cube root. If I wanted the cube root of 8, that means I need something times itself 3 times, because my index, that number on top of the house, is 3. So I have to figure out how can I break up 8 to where I can get 3 of the same thing. So if I need to, I come on side and I do my little factor tree. 8 is 4 times 2, and that 4 is 2 times 2. So I have 1, 2, 3 2s. Now I have 3 of something. So I get to take it out one time. I have 3 2s, so I write a 2 one time. And that's the way the cube root works. Notice that once I'm writing these answers, you no longer see those radicals. And that's because I've taken everything out from underneath that house. So there's nothing left as part of the radicand. So I don't need the square root or the cube root or whatever root anymore. This 16 is a perfect square. That's the reason why the answer came out to where it came out a nice, pretty number. If it comes out where it doesn't come out a nice, pretty number, it's not a perfect square if I'm taking the square root. Okay? For it to be a perfect square, when I take the square root, I have to be able to get an answer that doesn't leave me with a decimal. If we look at, let me write that down. It helps if I can spell it correctly right. If I try to get something like the square root of 7, seven is just 7 times 1. So there's no way for me to find a number that I can multiply times itself to get that 7 exactly. And when that happens, we say that that's irrational. You can think of your irrationals in general, beyond the roots, as things where the answer comes out funny, whereas these decimals that just never end, and they're not like a 1/3 where when you change it to a decimal you have that 3 repeating. There are these weird things like these square roots of 7. So what we're going to have to do is we're going to have to simplify these radicals, but not just with the numbers. We're going to have to throw some variables in there. So let's make certain we understand how this would work for our variables. If I had something like the square root of y to the 6, I still have to clean this up with the same idea of trying to find 2 of something. And the reason why I'm saying 2 of something is because it's a square root means there's an invisible 2 right there. So I can kind of work this the long way. Y to the 6, that's just 6 of those y's that's sitting up there being multiplied together. And so here I have a set of 2 y's. Here I have a set of 2 y's. Here I have a set of 2 y's. And I'm picking sets of 2 because of the square root. For each one of those sets that I've circled, I would be able to take a y out. So I'm taking 1 out for this one out for that one, and 1 out for that one. And when I take them all out, I'm taking it out, and I'm using multiplication. So I have my multiplication symbol in between. So I have y times y times y is just a y cubed. And that's my answer. Now there's a quicker way to get the answer. If I take this 6 that was right here, and I divide it by that 2 that was my index, and this works for our exponents only, I can take that exponent, I can divide it by the index, and the answer I get as that whole number is what I get to take out. So we're going to do some where everything comes out, then we're going to come back and do some where when you start taking your sets out, you don't have enough and you have to leave some stuff behind. And then this is going to change up just a little bit. Okay? So let's look at some examples. So let me clean my board. And the examples are going to say to simplify. And our first example is here. We have to simplify the negative square root of 64 y to the 18th. Now see that negative is sitting out in front of your radical? So it's really sitting there like a coefficient. So that's just like a -1 being multiplied times an x. It's just that like a kind of like a coefficient, just sitting right there in front. Okay? And so when I go to clean up that square root of 64 y to the 18th, I'm going to clean that up and I'm just going to drop that negative down for right in front of it. Okay? Because it's just saying whatever the square root of 64 y to the 18th is, it's negative now. So I need to think of what times what will give me a 64. Some of you already know the answer. Some of you may know. So 64, I got to think of two numbers. And I'm going to take the long route. Let me warn you now. So let's pretend I really can't think of two numbers that multiply to give me that 64. So I'm doing my factor tree. And so the first thing I think about is, well, 2 should be able to go in there, right? So I do a 2 times a 32. Okay. And I need 2 of something, and I don't have 2 of something. Well, at 32, I can break up to 2 times 16. Okay, now I see I have a little something going. I have some 2s I'm going to be able to get from here. Because these are prime. I can't break those 2 up anymore. But this 16 is in prime, so I may be able to break it up some more. So I need to look and see if I can break it up some more. And then we just talked about 16 being 4 times 4. And even though that's not prime, I know it's going to make a set. So I can stop there. If I don't know I'm going to have a set, then I just keep breaking everything up. Even if I have to break it all the way up to my prime numbers. So when I rewrite that 64, I'm going to write it as 2 times 2. And then I'm going to grab these 2 4s. I need my sets of 2. I have a set of 2. I have a set of 2. So I'm going to pull out a 2. I'm going to pull out a 4. Then I have to think about that y to the 18th. So my 18, I'm going to divide by my index of 2 and get a 9. That means I'll be able to take out 9 of them. So now I have 2 times 4 is 8. 8y to the 9th. Oops. I forgot to carry down my negative. Negative 8y to the 9th. Now if I recognize that 64 is 8 times 8, then I'm here a whole lot faster. Okay. Doesn't mean anything if I have to take a few extra steps, because I just need to make certain I can find out the numbers. Let's change this one up a little bit. What if that negative was inside the square root? With that negative inside the square root, that says I have to multiply something times itself and get a negative. Well, that means if I'm multiplying it times itself, it's either going to be a positive times a positive, or it's going to be a negative times a negative. And neither one of those is going to give me a negative answer. So I'm not going to be able to find a number that I can multiply times itself and get a negative answer. So that's make-believe stuff. So this is not a real number. And what it actually is, it's an imaginary number. So we're going to know that we have, and we're going to come back to that imaginary later on. We're going to know that we have something that's not a real number whenever we have, come up here, if your index is even, and this is a negative number. That's when we say not a real number. And we're saying that until we're able to learn how to clean this up. Once we know how to clean this up, we're going to go ahead and clean it up. Let's do one more example. This this time, let's make it a cube root. So now instead of trying to find 2 of something, I'm trying to find 3 of something. And we'd already started breaking up our 64. And so that's not good enough, because we don't have 3 of something yet. So that means we need to look at that 64 again. So we already had 2 times 2 times 4 times 4. Okay. So now I'm going to take this 4 and I'm going to break it up. So I know I have 3 of something here. I still have a 2. This 4 is in prime. So I'm going to see if I could break it up to get some more 2s, and I can. So I'll have everything that I need. Now in terms of that negative that's sitting in front of here, this is an odd index. I can take a negative times a negative times a negative and get a negative. I can multiply a negative number times itself 3 times and my answer comes out negative. So this is fine. All I'm going to do is pull my negative out front. The time I have to worry about it is when the index is even. So when the index is odd, I'll be able to pull it out. And notice I didn't even worry about it here, because I know I'm automatically going to pull it out front. Like that. So now when it's time to deal with that 64, my index is 3. Here's a set of 3. Here's a set of 3. Now I have to deal with the y to the 18. So I'm going to take my 18 and I'm going to divide my 18 by 3 because 3 is my new index. I'm getting a 6. So this will become y to the 6 that I'm able to take out. Now I clean that up. Negative 4 y to the 6, and that's my answer. So this is what happens when we're able to clean everything up. So then we're going to look at what happens when we're not able to clean everything up, and then we're going to summarize all of that.